Maybe we'll get going. We have just a few people on the line today, but we're going to record the webinar and make it available for anyone who goes to the Wiki Watershed website, as well as send it out on the DRWI news wire through Basecamp. I'll send the audio over to Scott Haig at the Academy for some introductions. Go for it, Scott.
Okay, thanks, Dave. So just quick background on what the technical user group is, and that's the group that's putting together this webinar series. The technical user group is a relatively recent creation as part of the DRWI, and we're a group of organizations and scientists that have been building support tools for William Penn for DRWI, and we've gotten together to work on coordination of tools and data and to help sort of plan the vision of what are the changes to these tools to make sure they're as useful as possible moving forward. And I just say that these were the first 4 seminars that we had come up with as we thought useful topics, but Dave and I are interested in hearing if we have other topics for other webinars. And lastly, the TUG group, we meet once a month by phone, but we keep track of the meeting through an executive summary, which is on Basecamp in the technical user group document. So if you want to see what we're working on or if you have any questions, that's a good place to start. And so today we're going to have a presentation by Dave and Anthony on Wiki Watersheds, and they're going to go through some of the features of the tool and how you can use it. So I'll turn it back to Dave and Anthony, and thanks for joining us.
All right, thanks, Scott. And I'll just back up, recognizing that we are recording the webinar and we'll post it on a website where the resource will be available to people anywhere in the world, and they may be wondering what is DRWI. The Delaware River Watershed Initiative is an initiative sponsored by the William Penn Foundation to promote and advance conservation and restoration strategies on the land in the Delaware River watershed. And the initiative is sponsoring more than 50 nonprofit organizations, academic centers, et cetera, to implement the work, mostly with agricultural landowners, but also with forest protection and some suburban areas to advance or protect and improve water quality in the Delaware. All right, today's webinar, I'm going to share, Anthony and I are going to share a little bit about Wiki Watershed in general, but we're going to focus on Model My Watershed as a tool for project planning, implementing best management practices in your neighborhood. And the outline today, I'm going to provide a very quick introduction to the broad program or project called Wiki Watershed, and then we'll demo Model My Watershed. We're going to learn how to delineate an area on the landscape and discover data pertaining to land use and other data, monitoring data as well, run hydrologic and water quality model. We'll build and model a best management project scenario or best management plan scenario, and then compare the results to determine reductions in certain water quality pollutants, namely sediment, nitrogen, and phosphorus. We'll also demo some new and exciting changes or implementation within Model My Watershed, a variety of features. One of those is incorporating the Stream Reach assessment tool that Scott Haig and colleagues at the Academy had developed into Model My Watershed, which is now part of a sub-basin modeling routine for nutrient hotspot identification. And lastly, we'll connect to showing you how to save and share your project with a couple different resources within the web application. Anthony Alfenkamp's on the line from Limonotech as well. He's going to jump in anywhere where I may have left out some details, and he'll join maybe more at the end with the information on sharing your project in HydroShare. I'll start by sending out thanks and acknowledgments to a variety of team members that are on on the Wiki Watershed team. There's quite a few folks that have made this all possible. So thank you to all of our partners. The funding for this project has come from the William Penn Foundation, the National Science Foundation, and a variety of other funders. So thank you to the funders as well. So what is Wiki Watershed? It's a web toolkit to support citizens and conservation practitioners, researchers, students, educators to advance knowledge and stewardship of our freshwater environment. And if you go to wikiwatershed.org, you'll find that it's a portal or a gateway to a variety of resources that relate to watersheds, water quality, and monitoring and information about your watershed. We're going to focus on the top two today, the Model My Watershed web app and some Monitor My Watershed tools embedded in that web app to discover water quality monitoring data as well as other data pertaining to the land cover, land use. So what is Model My Watershed specifically? This is a web application, happens to reside on the Amazon Web Services for watershed modeling. And as I've already introduced the workflow in an earlier slide, this allows you to zoom into a parcel of landscape or an area on the landscape, discover a variety of geospatial data there in your watershed or neighborhood to model stormwater runoff and water quality using professional grade models, compare scenarios or implement best management practices on those landscapes, rerun the models and see how nitrogen, phosphorus, sediment, and hydrology may change with the implementation of these best management practices. So our focus in developing this tool has been to provide something that's relatively easy to use, that's based on scientifically sound modeling algorithms and information that's out there, and to try and provide the user with up-to-date information on land use and a variety of other data layers. It's freely available at wikiwatershed.org, and we'll go there for a live demo in just a moment. When we do go there, for the entire lower 48, you'll be able to access these geographic information data layers that provide information on the stream network, air temperature, precipitation, elevation, slope, the hydrologic soils group, which tells us how water moves through the soils, and the National Land Cover database. We have a variety of technical documents and learning tools that are also available if you're interested in finding out more information about these data layers. What you won't see today are some added improvements that we're really excited about that should be coming in a future release of the web application by the end of the year. Here's one example. We're incorporating the active river area. This is a data set from the Nature Conservancy, and the spatial extent of this will be for the Northeast and Mid-Atlantic regions in the United States. We are also incorporating products derived from Shippensburg University that have been produced in the Delaware River Watershed Initiative framework to estimate or project land changes to the urban area in the Delaware River and a little bit on the surrounding areas as well. So these are our urban land scenario changes out to 2050 based on different types of growth models. And lastly, I don't have a layer to show you, but we'll be adding a preserved lands data layer, which will visualize the various preserved lands within the Delaware and surrounding areas. I believe that'll be national as well. So let's get right into the web demo. Here are some web links for those of you who want to go and test out these resources yourself. I'm going to now slide over to my web browser. And when you go to wikiwatershed.org, here's the landing page. There's a variety of tools to explore, as I've already introduced. So scroll around, click on some things, have fun exploring. There's some help documents under the help to find out more information, and I'll come back to that shortly. We're going to get right into Model My Watershed and launch the web app. If you're brand new to the web app, the first screen you may see will ask if you would like to register as a user or use the application as guest. To register as a user, it's free. There's a minimal amount of information you need to share with us. And once you become a user, you'll be able to save and share your projects and connect your projects to other resources on the web. And we'll demo that a little bit further on in the webinar today. First thing you should notice is the Layers tab down here. You can minimize or expand that layer tab, and there are a variety of geographic data layers that can be clicked on, toggled on or off for you to visualize. This is the USGS streams layer. That's a national stream layer. We've also added a Delaware River Basin high-resolution stream network, and as you zoom in, you can see the detail improves the closer you get to the landscape. This data layer maps potential very small streams, and I can provide links or information to learn more after the webinar with any questions. A couple other tabs to quickly toggle on and off. National Land Cover Database. Here you can see a key to the colors by clicking on the information icon just to the right. Hydrologic soils group, and the variety of the other data layers that were introduced in the previous slide. Rather than go through the rest of these, I encourage you to explore all those layers, and let's just get started with a project. What I had hoped to share with you is an example of a project that our team within the Christina River Basin cluster of the Delaware River Watershed had done for Phase 2 planning in the Honeybrook area in the Upper Brandywine. And so I will try to find that quickly as we move around. Here's Honeybrook, Pennsylvania. And once we hit the Get Started, we have options to define our area of interest. I'm going to delineate watershed by clicking on a point with the Continental US Medium Resolution tool. By clicking on that, it'll enable a pin drop, and I'm going to zoom into the area where I know that we've done some planning for restoration purposes. I'm going to click on the map and drop the pin, and this will delineate the watershed above that pour point for where the stream continues downslope. And as it's delineating that area, it then uses the area to process all of the data layers that are available here: stream network, land use, soils, terrain information, point sources, animals, etc. You can find out more information with help tools. For example, here, if you're interested in what is the National Land Cover Database, you can click the information icon and open then a link, potentially, to a technical document. And I know why that's not working, because I have my pop-up browser on. And so turn off any pop-up browsers if you want full functionality. And then you can get into a technical document right away while you're performing your workflow. Soils data, etc. We can continue to go through the various data layers to explore this information for the area of interest. The aim of delineating this area, though, for project planning purposes was to run a model to predict how water moves through this landscape and what the potential is for nitrogen, phosphorus, and sediment to find its way into our waterways. There are two models to choose from. I'm going to, for this first example, I'm going to stick with the Watershed multi-year model. I think most of our users on the webinar today know this model as MapSheds that Barry Evans developed at Penn State, and we've been working to incorporate it into Model My Watershed. When we click on that option, it implements MapShed and runs the model. The model uses 30 years of daily precipitation inputs from nearby climate records and then estimates how that water moves through this landscape and partitions it into a variety of compartments: evapotranspiration, surface runoff, subsurface flow. It accounts for point sources, if point sources are within our watershed area, and then it estimates stream flow. All of these are estimates at monthly time steps, but the input data were from daily, 30-year average, daily average. You get the data table down at the bottom, and if you'd like to export those data, you can click on the Download Data tab and export them as a comma-separated value file and save them to your desktop. So that's the hydrologic side of the model output. Then there's water quality side of the model output, where we can view total loads for sediment, nitrogen, and phosphorus estimated by the model, loading rates, mean annual concentration, mean low flow concentration. The model also distributes loads into each one of the land cover types, and as well as estimates based on farm animals in the watershed, stream bank erosion, point sources, and septic systems. So we can see we have no point sources in this area of interest. The model is accounting for farm animals, and I should just quickly note that the farm animal data come from the USDA's county census of farm animals by county, and the model then is distributing those farm animals into my area of interest based on the ag area in this area. So that may be something that you'd want to adjust in future runs of this model if you know a little bit more about how many animals are in your watershed. I'll back up quickly and show you where you can find that information under Animals on the Analyze tab. So here are the estimates for chickens, cows, horses, pigs, sheep, and turkey. And this is another area we're excited about, a future iteration of the model. You will be able to modify these numbers to improve the accuracy if you have knowledge about the animal counts. It's not implemented yet, but the next release of Model My Watershed will include that feature. All right, so back to the model results. We have the opportunity to name the project, and here I'm just going to say Honeybrook, Phase 1 and 2 planning. And we also have then the ability to add changes to this area. Over here on the right-hand corner, just below New Project, I'm going to click on Add Changes, and this activates, first off, a new scenario over here on the left with a drop-down arrow that shows you can go back to current conditions or you can continue on the new scenario. And I'm going to name this scenario Phase 1 BMPs. And I'm going to add into this area then the conservation practices that the Brandywine Christina cluster implemented in this small watershed as a result of phase 1 of our activities within the Delaware River Watershed Initiative. And those were, there's a variety of choices here for best management practices. When you click on conservation practices, we had implemented cover crops, and you'll see when I click there, we have 520 hectares of row crop in this area of interest. And the team was able to document 113 hectares of those were indeed put into cover cropping. So when we implement that, the model reruns and updates its estimates. I'm going to continue to add practices. We had conservation tillage also implemented, the same amount of acreage, 113 hectares. We also implemented nutrient management, 113 hectares. We worked with farms for livestock and poultry management, and I believe the number was 20% of the animal units were modified. Deriving that number requires a little bit more knowledge about your project area, and I've basically asked our team here what their estimates were. So 20% for both poultry and livestock. And then they implemented vegetative buffer strips, stream bank fencing, and stream bank stabilization. When we click on one of these, the drop-down tells us the length of streams in ag. There's 4.5 kilometers, and of that, the team worked on 3 kilometers to implement vegetative buffer strips and stream bank fencing, and finally, stream bank stabilization. All right, so those were the best management practices that were implemented after a number of years of working in this landscape. And the model has finished updating, and now we can copy and paste these data or download those data into a spreadsheet. We can go back to the current conditions and also either highlight, copy and paste these data into a spreadsheet or download them. And I preloaded that information just to show you how one might do this. So what you see here is a table that are numbers of the current condition model output, where we have the source table at the top, and then the total loads at the top, and then each of the potential source areas with the sediment, nitrogen, and phosphorus estimates. And here are the BMPs from phase 1 that we implemented. And I've just built a simple formula in Excel to give me the percent reductions, load reductions for sediment, nitrogen, and phosphorus over here. So the estimate would have been 80% total load reduction for sediment, 18% for nitrogen, 55% for phosphorus. And then we can see the actual reductions that we gained in the various categories through this project. I'll just do a time check here. Anthony, for anything that I've gone through at this point, do you have any additions or things I've missed that might be helpful to share?
It looks good.
Okay. So I will just continue to show that we can add yet another scenario. And we went into phase 2 planning and with more projects in mind, and the team felt that they could work with landowners in this area to move up to 195 area of row crop and conservation tillage. And I'll just quickly put in the new numbers. For the estimates, of work done by the end of phase 2. If I can remember them offhand, livestock management was going to go to 35% and poultry to 35%. Vegetated buffer strips, I believe in this area, they had done all the work they could, so that remains at 3. And stream bank stabilization, 3. I think I got them all. Cover crop, conservation tillage, nutrient management, livestock, poultry. Good, I got those all. So the model updated again, and now I have a second scenario here that I can also name, phase 2 BMPs plus phase 1, and save that. And then again, I can go and copy these data and bring them into a spreadsheet and work with them down below and compare the changes for my phase 2 project. So the point here isn't to scrutinize the numbers. It was just to show you a possible workflow for estimating the impact of your existing and proposed projects. Once I'm done here, I may want to share this with my colleagues. Just by the fact that I am logged in, it automatically shares my work once I have run a model. So if I go to my project list, this project would appear at the top of my project list, and I could relaunch this project. But I can also share this by turning on link sharing. And now I have a URL that I can copy to my clipboard. I can go over to my email and email it to anybody I'm working with to share the project. When you share your project in this manner with your colleagues, it is not editable for them to use. They will just be able to view your project. If there are any edits, you would need to go back into your project, and you would still be able to return to that project and change. Well, let me see, it's not updating for me. Having a little refresh problem here. I think this has to do with the fact that I've done this too many times in the last couple of days. Yeah, I think something's stuck in my cache. You would be able to go back in and modify your project and change all the BMPs or add another scenario. I wanted to make sure I had enough time to do a couple other demonstrations for you, and one of those is to show you the sub-basin modeling routines that has incorporated the SRAT, the Stream Reach Assessment Tool that Scott Haig had developed and folks at the Academy. So this is now available nationally, but we will choose an area in the Delaware River watershed. To do sub-basin modeling, you must define an area of interest based on either the select by boundary option for USGS sub-basin HUC 8s or HUC 10s. For those of you who don't know what a HUC is, it's a hydrologic unit code, and it subdivides the landscape into different hydrologic units within a watershed. So you can just see the faint red boundary here, and this HUC 8 is the Schuylkill River flowing into Philadelphia. And once I click on this area with that tool activated, I think my machine just slowed down dramatically. Come on. There we go. That area is highlighted and used to clip the geographic information layers and other data layers, just like we did before. Once those are done running, we select the watershed multi-year model for this, to run for this entire area. This may take a few minutes, a few seconds. It's a very large area, and did this one earlier today, and it only took 30 seconds or so. So the model is running, and it's going to generate the estimates for the hydrology and water quality based on what might be leaving this area down here in Philadelphia. So we have the hydrology estimated for that whole area, and nitrogen, phosphorus, and sediment estimates. And you'll see right at the top of the table under water quality, it says View Subbasin Attenuated Results. This is the new feature that links you into this hotspot modeling. When you click on that, we are now running the algorithms that Scott and his colleagues have developed at the Academy to run the stream reach assessment tool. And it is taking those load estimates and distributing them into much smaller hydrologic units throughout this area. This may take a little bit longer. We are caching these data, so the more people that run this routine throughout the nation, we hope the faster the response time as more and more of this information is cached within the Amazon web system. Taking a, oh, is that Anthony, your phone? Maybe you want to.
Sorry about that.
You want to mute yourself?
Yeah.
This morning it went a little faster. I may be having some local networks. You can see the red polygons just showed up. So these will be all the subbasins now that are being rerun to distribute the nitrogen phosphorus sediment loads into each one of those subbasins, and in fact into even smaller subbasins within each one of these subbasins. So there's quite a bit of computational activity happening behind the scenes here. Let me turn on the streams layer to show you the stream network there. Come on. You know, while that's running, I'll run back over here. I'll step back over here to the Wiki Watershed website and remind you that under the help, you can click on documentation right there, and you have access to a variety of resources to help learn more. The most technical document we have is under documentation, and this reference document gets into quite a bit of detail, but would provide you with information to find the source data that we're using for each one of these. So if you're interested in where the streams data layer came from, you could go right to the source following this information. Let's check back over here, and we're still running the subbasin model. Does say may take up to 3 minutes. Okay, while that's running, I want to also share with you another exciting addition that's coming out in additions in functionality that's coming out in the next release. The best management practices that we had implemented in the watershed multi-year model, we had a limited number of best management practices, and the next release, we're going to expand the options to include no-till agriculture, conservation tillage, and reduced tillage categories. So there'll be more options to get a little bit more specific about the type of BMP in the rural environment that you can implement. And we are also going to provide a compare feature so that you can get a quick look at how your scenario has changed from the current conditions. So here's a screenshot that shows the surface runoff. The blue line would be the current conditions, and the red line would be the scenario that we implemented in that Honeybrook area with all of the best management practices. So you'll be able to compare both the hydrology as well as the water quality, and you'll be able to get a bar chart that shows the change in loads for nitrogen, phosphorus, and sediment. You'll also be able to see those data in data tables side by side. All right, hopefully, yes, the model finished running, so you have to have some patience sometimes, depending on your connection. So
I'll add something here.
Yeah, go ahead.
This is a very large HUC-8, first of all, and what we're doing is that we're actually running every single HUC-12 as an individual model run. And Dave, if you want to click on that list of HUC-12s, you can see them on the red outlines here. I don't know how many HUC-12s are in the Schuylkill HUC-8, but it's a lot. So every single one of those is running through 30 years of daily water balance calculations individually, and Dave's going to tell you a whole lot more about it. So the time that it took to run was long. However, there are a couple of things to just note. What we've built in a system that caches model runs. So in other words, the next time you run them, it will look up the previous results. So for every HUC-12. So this basically, we're training in the system to go faster and faster. And every time we create a new release, we kind of have to retrain the whole system. So if you experience a slowdown when you're doing any of this work, you could do portions of it separately, and that will speed up the accumulation of the total. Secondly, in our next release in November, Dave just showed you some of the BMP enhancements that we're going to release. We have sped up that 30-year daily water balance calculation by a factor of 4, and that gets really noticeable on the this subbasin modeling thing, because we have, you know, on whatever this is, on the order of like 40 different HUC-12s that have to all be run. A speed up of 4 is pretty noticeable. So anyways, sorry for that interruption, but I just wanted to describe how speed and performance are really at the top of our minds, and we're doing a lot of work to optimize that.
Yeah, no, actually, thank you for the interruption. Scott, was that something you wanted to add?
No, I was just going to say there was a question in the chat about adding forest BMP, and I don't know if you want to come back to that later. I just wanted to say that.
Yeah, that's a good point. One of those other additions, it probably won't look like it does here, where we have options for conservation practices, these best management practices over here, but we're building another table that will probably appear right next to conservation practices that will allow you to change land use in this area, not just adding forest or removing forest, but any of the land use categories. So if you know that you have a brownfield site that's going to be put into forest, or a farm that's converting to an urban environment, you'll be able to change the acreage in a table and update the model with that new land use information. So that's a real good point to add, and an exciting development that will be available by the end of the year. So back to the subbasin results here. As Anthony mentioned, I picked a very large HUC-8 basin to do the subbasin modeling, and he noted how many HUC-12s there are. Each HUC-12 is listed by name here, as well as their HUC number. This number is a USGS number, so you should be, if you want more information about that HUC, you could probably use that to find out more elsewhere on the web. And then the area, the sediment, nitrogen, and phosphorus loads that are predicted by the modeling routine, loading rates as well. And when you click on any one of these HUC 12s, you can scroll to any one. If you click on it, you'll see the map zoom to that HUC 12. And within that HUC 12, there are other subbasins that have been isolated, and now you can visualize, you have a visualization of either the total nitrogen, total phosphorus, or total sediment relative amounts based on this color ramp here. So those colors correspond to the color ramp down next to the Layers tab. And of course, you can also make that transparent if you're interested in potentially looking at the land cover or the satellite image underneath those to sort of get an idea of what the land use is like, or even look at the land use map underneath that total phosphorus layer. So there's sources for that HUC 12 shown here for nitrogen, phosphorus, and sediment. But when you click on catchments, you'll see that each one of these even smaller NHD plus catchments is isolated. And as I mouse over them, you'll see the little black outline highlight which one we're hovering over. And you can get the area as well as sediment, nitrogen, phosphorus loads and loading rates for each one of those. I believe you can also download those data to a comma-separated file if you wish to work with those. So right now we're visualizing phosphorus, but you could choose total sediment, total nitrogen, or total phosphorus to visualize. And to then go back out, you hit the back button, and you can choose the next subbasin that you would like to interrogate and understand where the potential loads are coming from within this segmented landscape. Scott, is there anything you would add to these calculations or more information you feel that should be provided?
Oh, sorry about that. I had you on mute. No, it's just that the assumptions that are made about flow are coming from a national data set. So just to take that into account when you think about the volume of water, it's the yearly average flow. So any water quality sample you may have in stream is, because this is all yearly average modeling, you can't really compare your in situ measurements necessarily directly to the modeled estimates. You'd have to model them back to get the yearly sum. And so that's just a question we've gotten a lot about this feature. I think that actually is true of map sheds in general too.
Okay, thanks. So we can hit the back button and go back to the original model run for the entire HUC 8. And we could then add changes to this area and develop new scenarios, et cetera. Before I move to the next or the last few points that I'd like to make, I want to share with you that for any of these runs using the Watershed multi-year, aka MapShed, you can download a file called a GMS file, export GMS file, that is the file that is required to use the desktop application MapSheds. And that desktop application is still available for free to download and install on your desktop. And you could open this GMS file and use a whole set of more detailed tools to modify your project, to change BMPs, to work with different animal counts and other best management practices. We will be providing that in more detail in our future webinar that we've coined the model my Wiki Watershed 2. I forget what what we do. Wiki Watershed 2, power users of map sheds and multi-year models. So we'll be going into detail with that probably in October. We have to set the date still. Anthony, were you going to jump in there?
Yeah, I was just going to say it's going to be essentially power users.
Yep. And all right, so we have about 10 minutes left. There's one last point that I'd like to show you with regards to sharing your project. And this is still a little bit bumpy. We're ironing out the potential pitfalls of doing this, but we've implemented a different type of sharing opportunity to connect your project to a resource, archival resource called HydroShare. HydroShare is this online, basically data sharing and archiving website that is curated by QUASI, the Consortium for the Advancement, Consortium of Universities for the Advancement of Hydrologic Sciences. And in order to export to HydroShare, you'll need to have a HydroShare account and connect that account to your Model My Watershed account. And I've already done that. I'll show you where you can do that in just a moment. But when you export, you can, name, what was this, I don't know, Huck 8 demo. And you must type in an abstract, and you can export that to HydroShare. It does take a while sometimes to do that, and sometimes you may have an error that we're still trying to figure out. But in fact, even when it returns an error, you'll see that your project information is showing up on HydroShare. So
I'll point out that the error is mostly understood and mostly fixed. I mean, it's entirely understood and mostly fixed, and will be also up on the next release. So so go ahead, Dave.
Yeah. So there's going to be a whole nother webinar on how to use HydroShare that'll go into more detail. But here's hydroshare.org landing page, and I'm already logged in because I preloaded this. Once you generate a login, there's a My Resources tab that you can click to, and you'll get a list of all of your projects, not just Wiki Watershed, but any other data that you may have loaded into your resources. So you'll see right away here that this Huck 8 demo has already been transmitted to HydroShare. And when I click on that, I open that up within HydroShare to find out more information about that resource. HydroShare automatically generates a nice citation string that you can use to share with colleagues or potentially put into a publication if you're referring to your project. And you'll see a collection of files that have actually been sent here. Rather than downloading each CSV in the Model My Watershed web app, you have access to all of the data files under sort of one repository here, as well as you have the area of interest saved as a GeoJSON that could be imported into another geographic information system that you might use. You can further annotate your data and
also as a shapefile. I think if you scroll down that box, there should be a folder, or did it time out?
It's still trying to
yeah, okay.
So we can open a different one where we have the shapefile. And this was one that my colleague Charlie Dow shared with me, and I brought over into my account. And here the area of interest is in a folder that then has the shapefile for that area right there. There are some resources then to open with Model My Watershed, or to make it private or public, and to share it with anyone else who has a HydroShare account. So the last point, I'll just show you, under your account, My Account information, we can see linked accounts in the upper left corner, and you can see that I've connected my account to HydroShare. The first time you do this, you'll need to log into your HydroShare account to make that connection in order to save your projects to HydroShare. Let's see, I'm just looking through my notes to see what else I missed.
Have we gone through monitor functionality?
Thank you.
And while you're queuing that up, I'll just say part of the point of this whole HydroShare thing is the push by the William Penn Foundation to share data more publicly and to basically ease the sharing of data. They commissioned an expert panel of people outside the DRWI, and that panel recommended HydroShare as one of the platforms that could receive data of all sorts. And we're going to give you a brief, as Dave clicks on Monitor, which is the beginning capabilities for us to, for us to, Dave, if you go to the Brandywine Christina Huck 8, you can see a bunch of stuff from HydroShare, which is kind of fun.
Whoops, sorry.
Yep, that should work. Oh, no, wrong one. So anyways, HydroShare has lots of capabilities for automated data sharing and retrieval and searches. So anything that gets shared in HydroShare gets reshared amongst all sorts of federal and other data catalogs. There's it basically follows these recommended virtuous data sharing principles that the Open Data Initiative from the last the Obama administration promoted, and all federal agencies are now working toward. So as you can see right here, Dave has clicked on Monitor. He's seeing HydroShare resources, including if you type in Creek or something like that. Oh, you've already got some of them right up here. Like if you type in
my search term was water.
Yeah, perfect.
General, so I have many resources that have come up.
So some of those are data sets that have been loaded up by academics, or this is into HydroShare itself. Some of those are the Model My Watershed HydroShare modeling projects that we just discussed. If you go back, Dave, those big squares are over the top of New Garden, and yeah, if you click on those are, I'll go to the second page of that. Maybe go to the bigger square, because one of those is a HydroShare project for White Clay Creek. So maybe it's not showing up underwater. Yeah. There it is, right there, White Clay Creek at Delaware Line. Yeah, that's your model project.
Oh, yeah.
Yep, on HydroShare. So that's showing up. Lots of other data are also showing up in HydroShare. But we're not limited to HydroShare. You might see that there are other tabs that we have here. The Quasi-Water Data Center. Why didn't that work?
No, it's coming.
There we go. It's coming. Is stunning. There are 3,797 data sets that are listed there. And you can do some free text search to find ones that are more relevant. You can search specifically for USGS. Most of those are USGS groundwater. If you search for discharge or turbidity and research, hit enter, it will filter. There's a stunning amount of monitoring that's going on in the Brandywine Christina system. And you can get, if you click on one of those, Dave, any of those, it might be useful to just see when you click on these resources, you can actually see data.
Yeah, I'm just, there's trying to get a relevant or a recent communication. So now this is a USGS stream gauging site that also has water temperature, and the most recent data looked like came in the 30th, but there is the ability to visualize all the way up till September 6th.
Yeah, the data should be completely current. It's the catalog that doesn't update its most recent data as quickly as it should, and that's not really something we can do about. But when we fetch the data, we're fetching the real latest live data. Looks like there was a data outage. Oh, you got to have a different period now.
Temperature, yeah.
Oh, the temperature's from a long time ago.
Yeah. So that wasn't one of their best stations. That's I think down here, probably one of these.
Chad's Ford's a good one. So
this one's a good one too. This one even has pH.
And if you click on that source data link up above, you end up on the USGS website. It's actually a pretty handy way to just find USGS data and other data.
So I'll just add, because we're just about out of time. We want to have a few questions here. We might be starting to lose some people. We have 3 different data warehouses in here: HydroShare, the Water Data Center, that's also a quasi initiative, and then Synergy. Anthony, can you give the acronym of that one?
Yeah, it's like Community Interoperability Network for Resources in Geosciences, or something like that. It's
for folks on the line.
Yeah, it's a massive kind of catalog of catalogs. And then we're about to release, and most of these are kind of big regional data sets, but you can find interesting things there. Also, we're about to release, in the next release, we're about to have a way to peer into EPA STORET through the new joint EPA-USGS water quality portal, which is kind of the new user interface to STORET, and that's actually very exciting that we're about to connect all that up to.
Yeah, there'll be hundreds of thousands, if not millions, of data points that will be available to discover nationwide. All right, so that just about concludes our time we set aside for the webinar. Happy to answer questions that may have been submitted. How is the SRAT de-aggregation of results different from the Model My Watershed application to a small watershed? Which is better approach in your opinion? Scott, are you able to handle that one?
Yeah. So what SRAT does is it really reapportions the larger model to the smaller model using a sort of a fast reapportionment technique. So if you're going to look at a small area, I would suggest doing it with NapShed, the base model, because that's going to do some more complex things than the SRAT tool is going to do. The difference is, of course, if you want to compare lots of different small watersheds to each other, then SRAT's going to be the way to do that. So that would be my answer.
All right. If anyone else has a question, go ahead and type it in. I'm not seeing any others come through. If there's no others, I'll just let you know that as you exit the webinar, there are 3 very short questions. I'd love to hear back from you on what you may have experienced with this webinar, and I believe there's one question in there that'll help us plan for a future webinar, the advanced version. So thank you all for joining, and if there are any parting words from Anthony or Scott, go for it.
I was just going to say that our next webinar is planned for 2 weeks from now, and we're going to be looking at field docs and a tool that's being developed at the Academy to help track metrics for DRWI. So that's next up. Thanks for doing this, Dave and Anthony.
Thank you for organizing it.
Yeah, and one last point, we will have the recording available on the Wiki Watershed video resources in the next few days, and we'll share that out with through Basecamp with our DRWI colleagues. All right, that concludes today's webinar. Look forward to hearing from you all. Don't hesitate to contact us about the information you've heard today. Thanks.
Thank you, Dave.
Oh, bye. Thank you, guys.